Hello everyone. Welcome back to Python Challenge for All. Okay, so let's continue our work with graphviz. Okay, graphviz is a tool to draw a graph out of dot description. Okay, so last week we used browser web-based services to input dot language and change that to graph visualization results, like we said, like we saw last week. Given the graph description, the language starts with graph or digraph, graph name, and curly bracket in there, lots of nodes and their connections. And if you click generate graph like this, we can draw a graph. And actually, we can do it using Python too. So let's take a look. So this week again, we will go back to Google Colab and play with it. Okay, so go back to Google Colab. So make a new box, say graphviz. Okay, and so using in Google Colab Python. So workflow is import graphviz, write dot source, and display. Simple, okay? So let's do it. So first thing is import graphviz. Yeah, it's already installed. So just this line will do. Okay? Let's enlarge a bit. And then, so very easily, one way to do that is graphviz dot source. We give source, and here we give a string. So say digraph, name is say x, and curly bracket, say A goes to B, semicolon, A goes to C, semicolon. This is what we wrote maybe last time, D. Okay, this is all, semicolon. Okay, so if you run this one, so now we have the graph. A goes to B, A goes to C, and B goes to D, like that. So this is the simplest way. Just write dot language in quotation mark here, okay? So this is a way to, basic way to visualize source code. But what happens if the source code is long? In that case, yes, use triple quotations for long text source. So let's see. Let us try. Let us try in this here. Instead of doing this, okay, you can write, for example, dot equals. Dot equals and triple quotes, and then write like digraph x, and then as you like, A goes to B, semicolon, B goes to C, semicolon, B goes to D, like this. B goes, no, the second line, I want to make consistent. Okay, A goes to C and B goes to D. And then, yes, close the source by triple quote and write the same thing. Okay, graphviz dot source and dot. And this will draw a graph just like the previous one. Okay, so next, or you can save the graph in an image file. Okay, in that case, graphviz.source and render to fig. Okay, for example, in here, you can write, you can do the same thing as dot render and fig. Okay, for example, the file name and the format equals PNG. Okay, if you do this, okay, what you see is in here, two files are made, fig and fig.png. So this fig.png is just the same graph in PNG format. So once you have this file, you can run it by displaying it by this line, okay? So graphviz dot source, yeah, right. And then open fig file and read it. This line will make, let's make this in a new box instead of the same box. Okay, make a new box and write it. So in this case, this file will be read. And if you run it, you can take a look. You can visualize the image in fig file. Okay, good. So actually, yeah, let's see one more example. Okay, for example, if we copy this and instead of dot, last time we draw a social network thing, right? So we copy the same code. Oops. We copy the same code from here, my cheat sheet, and paste it here instead. Was the long line. So it will draw a graph that's exactly the same graph as this. Okay? Just like last time, if you uncomment these two lines, there will be new connection of Bob Frank and Erin Grace. Okay? In addition to this, we can make new connections. Yeah, neighbors. Or, yeah, you can see there's a romantic relationship between Carol and Dave. And also, you can do some kind of, you can specify the allocation of the position like this by putting Alice, Bob, and Carol in a horizontal array, horizontally lined. Okay, this is one example of taking a rather long graph, a long dot description into graph using Python. Okay, what's good? Furthermore, what's good about using Python is that when we do some experiments, we have some relations listed in a list like this. Okay, in this case, we can use this list and make a new graph automatically. So let's try that. Let's take a look some of these examples. So here we make a list of, say, connections like here, Alice, let's see, Alice and say Bob. Okay, this is the first connection. Oh, no, no, no. Yeah, connection should be in tuples. Okay, tuple 1, B, A, and B, Alice and Bob. Okay, next connection is, say, Bob, Alice, and Carol. Alice and Carol. Next connection is, say, Bob and Dave. And one more is Carol and Erin. Okay, Carol, let's make a tuple. Okay, Carol and Erin. Okay, it's like this. There are, say, 4 connections. And from there, we can make, first, we initialize a list graph as graphviz dot graph and name it as, say, relation. Okay, And then connect it. Given the list, we can connect one by one. Okay, prefer every graph and connect using the list. So for all the elements A, B in L, we connect G dot edge A and B. This is all. Okay, we run it and get the graph. So if you just print G, let's take a look inside G. So this is all, okay? Alice to Bob, Bob to Dave, Alice to Carol, and Carol to Erin, like this. Of course, we can add more if you want more, like Alice and Frank and Alice, okay, sorry. Alice to, again, Frank, like this, okay? And then if you run it and take a look, there will be new connection like this. So this is an interesting way to given a list of connections, we can visualize it. You automatically visualize it using this graphviz capability. So this is very useful for experimental results visualization or survey result visualization. I hope this will help you in the future. Okay, that's all for today. Thank you very much and come back again. Bye bye.